Okay, 2.2, proving lines are parallel. Okay, everything the last 3 days have been if these lines are parallel, this is true, correct? So now we're going to go the opposite, and if this is true, the lines are what? Parallel. So we're going to be doing those.
Yes. Yes, she was speaking in English. Maybe if you would listen.
I wasn't.
Okay, so everything we do today is going to be the converse. Converse means opposite direction. So alternate interior angles. If two parallel lines were crossed by a transversal, the alternate interior angles were congruent. Yes? Yes? So now we're going to go opposite. If the alternate interior angles are congruent, then the lines are what?
Parallel.
Parallel. We're going to go backwards. So, converse of the corresponding. Converse means opposite direction. Got it?
Yeah.
So, converse of the corresponding angles theorem. If two
For
lines...
juniors and seniors in Nebraska Wesleyan Rapids in the Counseling Center, if you'd like to visit with her. Juniors and seniors interested in Nebraska Wesleyan.
What's that?
Is report down
It's a
to
college.
counseling.
College. Okay. If two lines and a transversal form corresponding angles that are corresponding angles are supposed to be what? Congruent. Then the lines are what? Parallel. So if you have, this is your picture over here, you don't have to draw one today. I have two lines and I have a transversal, and they're telling me that 1 and 2 are congruent. How do I know 1 and 2 are congruent? They have that one arc, right? So they're telling me they're congruent. So if they are congruent, that tells me that line L and M are what? Parallel. So what could I add to my picture?
The little arrows.
The little arrows. So you get what we're going to be doing today?
Yeah.
They're going to be telling you things about it, and then you're going to have to decide if it's parallel or not. And why. So everything you're going to justify again. So this would be the converse of the corresponding angles theorem. So the next one. Converse of the alternate interior angles theorem. So alternate interior angle theorem says what? The angles have to be what? Alternate interior angles. What are they?
Alternate interior angles are congruent.
Are congruent, right? So if two lines in a transversal form alternate interior angles that are congruent, then the lines are what? Parallel. If they're not congruent, then the lines aren't parallel. So over here are alternate interior angles parallel. Congruent, sorry. Yes? So that tells me L and M are what? Parallel. So add your little. Now, if you guys would like color in your notes, they do make erasable colored pencils. That might be an option for some people that like to put a little color in their notes.
Where do you get those pens that rings?
Where do I get? I just go on Amazon and I don't get there's. I could show you. I'll show you. I'll send you guys a link or something. Because there's some that are really expensive and then some that are expensive but not even near. You can get them for 75 cents a pen rather than $3 a pen. Okay, so same side interior angles. Well, the last 3 days, same side interior angles. If lines were parallel, well, what? Same side interior. Supplementary. So now if they're supplementary, then the two lines are? Are. Okay? So if two lines in a transversal form same side interior angles that are supplementary. Did I leave you enough room on your line? Good. Then the lines are what? Parallel. So in your picture are the same, 1 and 2 have to equal what?
The same.
180. So angle 1 plus angle 2 equals 180 degrees. So what do we know L and M are? Parallel. So add your... Oh, yeah. That was, yeah. No, isn't that how it's supposed to go?
80 degrees, like backwards.
Why do you do them opposite, like the arrows opposite ways?
Just to show you it doesn't have to be the same all the time.
You didn't leave enough room.
For what?
Supplementary.
I just asked that. So your supplementary line needs to be longer?
No, it's fine. She just writes.
Okay, so it needs to be longer. I will note that. And actually I do think I made it longer, but after I printed. So I will check on that. Okay, so alternate exterior angles were what? If lines were parallel, they were congruent. So if two lines in a transversal form alternate exterior angles that are congruent, then the lines are parallel. So in my picture, are my alternate exterior lines congruent or angles congruent?
Yeah.
Yes, so the lines are parallel. And Gracie, I'm going to even throw you off on this one. I'm going to put 2. Just to show you I can. Okay, yes I can. So, are those all of the theorems we learned earlier this week?
Yeah.
Yes. Now we're doing the converse because we're going the other direction. So if they're congruent, then the lines are parallel. Not if the lines are parallel, they are congruent. Make sense?
Yeah.
Okay, so these I just gave to you. There's nothing to fill in, so look at them, please. Okay, if two lines are parallel to the same line, then they are what to each other? Parallel. So A and C are parallel, yes? Okay. B and C are parallel. So that also means that B and A. That's that transversal property. Remember yesterday you had to use that in your Math Excel, didn't you? Okay. So that's the transversal property. The next one says if two lines in the same plane are perpendicular to the same line, then guess what? They're perpendicular to each other. Again, the transversal property. So AC, that angle is perpendicular to this angle. So is this angle perpendicular? They're all perpendicular. Yes? Okay. Just so you know, I think that's one of those things we just know by now, right? But we do need to say it. So now let's get to your 2 examples. And guess what you get to do again? Draw a picture.
No, I hate drawing.
Okay. So on this picture, you don't have to do a big gate. I mean, you have a gate, right? So I got to draw this picture. So I'm going to take my marker and I'm just going to, if it was my paper, I would go, that's the outside, right? There's the middle. Do I even need the board? Well, yeah, I do because they have 1 and 3, don't they? So I need this board going across. Correct?
Yep.
Do I need anything else, like, other than angles? No. So then I have some angles I'm going to write on there. I know that they have angle, 2 here? And 3 and 1. And this is A, B, C. And this is a what kind of angle? Right angle. And this one over here is a, bless you, right angle. And they have V down here and what? W? I don't think I need that. Oh, yeah, I do. Are we good?
Is that a V or a Y?
That's a V.
Looks like a Y.
Well, I'm sorry, it's a V.
What's up, buddy?
Well, I'm going to erase in a second anyway and use this one.
Well, yo,
What?
what's that thing in the corner? Like, right angle.
Oh, there's an A
Oh.
and a V.
You have a degree right there.
Yeah, there's 35 degrees.
Oh, yes, I did forget a 35 degrees, didn't I?
Yeah.
Okay. That probably is going to be useful, huh? Okay, so it says, when building a gate, how does Bailey know that the vertical boards V and W? Oh, okay, so V and W are these vertical ones right here. Okay? So V and W are those. How does she know those vertical boards are parallel?
Because they both have right angles.
Well, okay, so this would be, if we're assuming they're parallel, right? So we have this line and this would be a transversal right here.
Yeah.
Yeah.
Okay. So I've got to meet one of my transversal rules, don't I? I mean, one of the rules I just went over.
Wasn't me.
Okay. Well, how are we going to figure these out? How does she know?
I don't know, probably something.
Well, you're gonna start with the 35 and you gotta find
Oh,
everything.
is this a transversal also?
Sure.
Yeah.
Is it? That one's going to do me more good because what do I have right here?
Right angle.
I have right angles. Yes?
Yeah, that's what
And if I have, I'm sorry.
I
Co-
think that they have right angles.
So they have, I had the wrong transversal though, didn't I? Okay, so I had to pick the correct transversal because there's actually 1, 2, 3, 4 transversals on those two lines, aren't they?
Sure.
Okay, so right here, I know that this is a right angle and this is a right angle. So those would be same side interior, correct?
Yeah.
And what do they equal?
90 degrees.
One of them's 90,
180.
180. Randy, what were you?
I was gonna say the rule is conversely same side interior angle theorem.
Right. The reason why is the same side, the converse of the same side interior angles theorem. And we just weren't there yet. She was right, but we weren't there. Xander, you had your hand up. Did you have a question?
Okay, that like 90 degrees, like the W
Mm-hmm.
and the 35 degrees. Like find one. Okay, would it be like 35 plus like?
Well, we have to make sure they're parallel first, and then we'll go from there.
They are.
Well, we'll go. Okay, so it says the question is, how does she know that V and W are parallel? Well, she knows because the same side interior angle theorem, correct?
Yes.
And 90 plus 90 is what?
120.
180. So we're good there.
What? Oh.
That answered that question, yes? Okay.
So
What? What?
I do have a question.
Yes.
Sorry. So with like right angles and like being in a parallel lines,
Mm-hmm.
and you know that it is a right angle. So will that always be same side interior?
Well, if you have the transversal that gives you that, yes. Because this one we have the transversal right here, so it forms that same side interior on those. Yes, Gracie?
Don't you need arrows?
A what?
Arrows?
Well, yes, but we're just not, it just says how do we know. You can draw them now if you want on your picture. If you want to put them on your picture, you can. Because have we proven it?
Yes.
Yes, so we know that this is parallel to this.
Yes.
Okay, so next one. What should the measure of angle 1, what should angle 1 measure to ensure the boards B is parallel to the board A? Now,
Now you use the one they go across.
Xander.
I did 90 plus 35 is 125.
Okay, so
180.
B is
minus
here.
125,
Yes, you were right.
and it's 55.
Okay, B is here. Yes? A is here. Yes?
Yes.
This is a transversal that crosses both of them. Yes? That includes angle 1. And Xander just said we have 35, and 1 and 35 are same side interior angles, yes? And what should same side interior angles equal?
180.
180. So we should take 180 minus 35 equals 574, 145. Alex, you taking notes?
I have it written down.
No,
Not that.
yeah,
No, not
you need to
that.
pay attention, please. And how did we know this? What did we use? The converse. The converse of the same side interior angle theorem, didn't we? We used it twice. So that's why I just draw an arrow. Save yourself some writing, right? Or you could do SSI. What's SSI? Side interior. What are you messing with?
Me?
You too.
I'm busy with my leg.
Okay. So, oh, I put C in front of it. What's C?
Corn.
Converse.
Oh, no, that's what I'm saying.
Okay. Bailey also needs board C to be parallel to board A. So I need C to be parallel to A. What should angle 2 measure? And why? Okay, so here's C. I got lots on my drawing. Here's A. Well, here'd be my transversal, wouldn't it?
Yeah.
Okay. So I know down here I got lots of stuff going on. Is it right angle? So what does this need to be? It also needs to be a right angle. So 90 degrees because you want what to work? The converse of SSI. What's SSI? Same side interior angles. Now my picture is looking like a complete mess, but is that the point of my picture? Yes.
Don't look like
Okay.
complete mess.
Is B parallel to C?
Yeah.
Why?
Because it said it is.
Because
No, we didn't.
I said it
We said that A was parallel
should be.
to B, and A was parallel to C.
So B and C are parallel.
So B and C are parallel. Why?
Because A and C are parallel.
Yes. Because A is parallel to C and C and B, yes? So A is parallel to C and A is parallel to B, so B is parallel to C. We used that last statement that I gave you, didn't I? All over one little gate.
I did it.
I can't stand how messy it is.
I know, this is bugging me really bad. But I wanted to show you the point. Your picture is for you to manipulate and draw on, correct? Okay, what would 3 be? We didn't ask about it. What is it?
It's gonna be a 90.
If-
It'll be 145.
It'd be 145. Why?
Because it's congruent to what?
Because it's vertical. Yes, Mercedes. Alex, focus up here. Okay,
Vertical and congruent are the same thing.
what?
Vertical and congruent are the same
Well,
thing.
vertical angles are congruent. Vertical is a type of angle. Congruent talks about its measures. Okay, if angle 1 is what? What's that symbol mean?
Congruent.
Congruent.
I see what
Okay, that's the congruent. It is the estimation put with a equals. Okay, so congruent to angle 2, which theorem proves that C is parallel to D? So angle 1, so we're going to draw on here, right? We're going to pick a different color. Ooh, orange. Orange. Okay, so we're saying that angle 1 is congruent to angle 2. If that is true, so C is here, yes?
Yep.
And D is here.
Yep.
So the transversal would be B, wouldn't it?
Yep.
Okay. So what theorem tells me that C is parallel to D?
1 and 2 are
What are 1 and 2?
exterior angles.
Alternate Interior.
Interior.
So the converse of the alternate interior angles theorem. And I just put a symbol for, because if you're like me, your paper is running out of room. Is your paper running out of room? No? Good. So the converse of the alternate interior angle tells you that. So now the next one says, if angle 2 is this and angle 3 is this. So I'm going to erase what I drew on my picture. Okay. So I have a measure for angle 3 and I have a measure for angle 2. Yes? For what value of x is A parallel to B? So here's A, here's B, and the transversal would be right here that links those two angles, yes?
Yes.
What angles are these to each other?
Alternate.
They're alternate exterior. So alternate exterior says what? That 2 and 3 have to be what? Congruent. So that means their measures are equal, yes? So what do I need to do with 4x minus 6 and 2x plus 18?
You gotta do the equation.
I have to do the equation, and that equation is going to look like 4x
X is 12.
minus 6. Xander, slow your roll a little bit. Okay, so if they're congruent, those two angles have to be equal, yes? Now you have an algebra problem that I want you to solve.
I cannot solve that.
You can too solve that.
So easy, girl. You're just dumb.
Okay, no, A, Alex, that is uncalled for.
It doesn't add a pocket.
What is your problem
It does still add a pocket.
Okay, shh. Everyone should be solving this and not talking. So Gerhard, if you're struggling, I'm going to do it up here. You can watch. Okay. Did you guys get?
Yes, I got that. This is all we did last year.
I know. So why aren't you guys doing amazingly on your first test on that?
I did. Alright, you listen here.
Okay. Now, I know what x is. X should be what? 12. Now I want to know what the angle actually is. How am I going to find it?
You're gonna put 12 inside the.
You're going to put 12 in it, right? So 4 times 12 minus 6. And I'm going to test it and take 2 times 12 plus 18 because they better equal the same thing, yes? So 48 minus 6 is 42. 24 plus 18 is also 42. Okay? So we've done this stuff, right?
Yeah.
Okay. You guys ready to go to the next one?
No.
Yes.
Okay, using the converse of the same side interior angles postulate. Okay, first of all, same side interior angles are what if the lines are parallel?
So,
Congruent.
yeah.
Wait, no, same side interior, sorry. Supplementary. So that means they equal what? 180. So I need to have all that in my head. I haven't even read the question yet, have I?
No.
All that in my head. What equation shows that G is parallel to H? So G and H, and we need to have same side interior angles. So you want the first line or the second one to be your transversal?
The first one.
The first one? Okay. So if I'm talking about the first line, my two angles I'm talking about are what? 1 and 3. If I chose the second line, I'd be using what? 2 and 4. Okay. So what equation, because it wants an equation, right?
Yeah.
You forgot your triangles.
So it'd be like
My triangles.
Your arrows.
Yeah.
We don't know.
We don't know that yet. It just says what equation does it have to be? Cody?
Would it be the angle 1 is congruent to
No, you just told me they're what?
supplementary.
They're supplementary. They're not congruent. Randy, you dropped the ball.
Angle 1.
So
Uh-huh.
Angle
Tony also
3
dropped the ball.
equals 180.
Angle 1 plus angle 3 equals
Right, Tony.
180. That's the equation. Okay, did it say to find angle 1 and angle 3? No, Xander. It said, what is the equation? So, you need to be able to build equations. Have you been working on building equations?
No.
Yes, you have.
No.
Hey, so that is all your notes for today. So I expect you guys to get busy on your 5, 6, 12, 15, 19, 20, 23, 24. Okay?
Miss.
Already got done, Miss Mick. Come here.
Yep. Xander.